So now we're going to talk about natural logs, and natural logs simply have base e. But we can't use log, that's common log, so we won't have a subscript, and we abbreviate it ln. Now you have to be careful because sometimes that looks like a 1. So sometimes I write it ln like that, so you'll know it's an L. On your calculator, there'll be a button like this, or I think mine's capital letters. Yeah, mine is like this. So you might see either one of those buttons on your calculator. But what does that mean? It means base E. Okay? So just remember that when you have ln, that's a natural log, and the base is E. Now, we're going to do this problem that talks about the domains of each function. Both of these functions are natural log functions, but it has nothing to do with finding the domain. So it's kind of weird that they put it in here, but we'll still do it. Okay, because what's the deal about the domain? The domain has to be greater than 0. It doesn't matter what the base is, it still has to be greater than 0. So if you subtract 3 from both sides, you would have that. You divide both sides by -1, but because you divided by a -1, you're going to have to flip the sign the other way. And so you're going to get the domain here, x is less than 3. So we're going from -infinity up to 3, and we're not going to include that 3. Can't equal 3, it's got to be less than 3. So that is the domain for that function f of x. And it doesn't really matter that it was a natural log, could have been a common log, or whatever base you want, but it just happens that it's a natural log. Okay. Now, when you think about these, this is kind of an interesting one here on B. You're going to say, oh, well, I'll do that the way I did the other one. When does x minus 3 squared, when is that greater than 0? Well, okay, that's a polynomial inequality, which we did those in section, I think it was 4.6. I'm sorry, 3.6. So if you need to go back and look at 3.6, that's how you solve a polynomial inequality. But you might remember, so you draw a number line and you find the boundary points. Well, this case, there's only one boundary point at 3, and we can't include it. So we don't want to know where it equals 0. It's got to be greater than 0. And it turns out, well, if you pick a test point, over here, say you put in like 0. So if I pick a test point of 0, well, you're going to get that to be 9, and 9 is greater than 0, right? So this side works. But if you pick a number greater than 3, like 4, and I'm plugging it in and I get 1, 1 is also greater than 0. So this side works. So, and if you think about it, when you square a number, isn't that always going to be greater than 0? Well, it's always going to be greater than 0 except one case when it actually equals 0, and that would be at 3. Okay, so I can have all real numbers except 3. The way we write that in interval notation, and some people miss this on the exam, but we need to write interval notation. The domain is going to be, oh, I didn't put a D for domain over here, sorry. Okay, the domain is going to be -infinity to 3 union 3 to infinity. Okay, so that's the domain. You're just going to have it be 3. And again, it didn't really matter that it was a natural log. Now we're going to talk about the properties of natural logarithms, so another chance to review the properties that we know so far. When we have a log of any base of 1, log base b of 1, that's going to just equal 0. We talked about that. So if I have the natural log of 1, that equals 0. Okay, property 2. If I have log base b of b, and the arguments matches the base, that equals 1. So if I have a natural log of e, that equals 1. Yeah, okay. So these are the properties we're going through. And now the inverse properties. If I have the natural log of e to the x, that just equals x, okay? So that goes by that property. I didn't write, I should have just written it underneath. I didn't write the base b one, but it says b log base b of b to the x just equals x. Remember, this is this important property that we're going to use a bunch. Okay. So the natural log of e to the x just equals x. Because see, we have that little e there that we're not writing. When we see the ln, we know that. Okay? All right. And then finally, if I have e to the natural log of x, oh, I did it again. Let me write the common one, or not the common one, the any base one. So if I have b to log base b of x, that just equals x. So in the world of a natural log, it's e to the natural log of x, that just equals x. Okay, so those are the properties when we look at them, and it's a base e for a natural log.